Section 7.1, Estimating a population proportion. In this section, we are trying to estimate P, which is population proportion. For example, the actual value of P is 0.75, and we don't know what that is, and we want to guess P. If I guess P equals to 0.6, this is not correct because P is 0.75. If I guess that P equals to 0.7, I'm close, but I'm still not correct because P is 0.75. If I say P is any number from 0.5 to 0.9, I'm correct because 0.7 is in between 0.5 and 0.9. So this is correct because the interval that I'm given is containing my P in here. What we're trying to do in this section is trying to find the interval that contains your P, which is population proportion. A point estimate is a single value used to estimate a population parameter. A sample proportion P hat is the best point estimate of the population proportion P. In order to estimate P, I am going to use P hat. Example 1. A poll was taken in which 1487 adults were surveyed, and 43 of them say that they have a Facebook page. Based on that result, find the best point estimate of the proportion of all adults who have a Facebook page. I want to find the best point estimate of the proportion of all adults. Proportion of all adults was the population proportion, which is P. The best point estimate of P is P hat. P hat is the sample proportion. So in this sample of 1,487 adults, there are 43% of them say that they have a Facebook page. P hat is 43% because this is the proportion of 1,487 adults, and which is 0.43. A confidence interval or interval estimate is a range or an interval of values used to estimate the true value of a population parameter. A confidence interval is sometimes abbreviated as CI. A confidence interval can be written in either one of these forms. This is called the interval format, and this is called the inequality format. So for the interval format, you're going to have your lower limit on the left and then upper limit on the right. Or you can also have the lower limit less than your population proportion and less than your upper limit. The confidence level is the probability 1 minus alpha that the confidence interval actually does contain the population parameter, assuming that the estimation process is repeated a large number of times. The confidence level is also called the degree of confidence or the confidence coefficient. The confidence level can be anything, but the commonly used confidence level are 90%, 95%, and 99%. If the confidence level is not given in a problem, always use 95%. There are many different confidence levels, but the most common use are 90%, 95%, and 99%. If your confidence level is 90%, in order to find alpha, you are going to take 1 minus 90%, which is 0.9. Your alpha is 0.10. If confidence level is 95%, alpha is going to be 1 minus 0.95, which is 0.05. And if confidence level is 99%, alpha is 1 minus 0.99, which is 0.01. The confidence level of 95% tells us that the process we are using should, in the long run, result in a confidence interval limits that contain the true population proportion 95% of the time. A critical value is the number on the borderline separating sample statistics that are significantly high or low from those that are not significant. When are you given a confidence level? That percentage representing the value that are not significant. It should be in the middle of your graph. Confidence level. Alpha are the one on the outside representing the values that are significant, either significantly low or significantly high. So these two ends add up to be alpha. So this is alpha half and this is alpha half, add up to be one whole alpha. And this value is z of alpha half, with area on the right is alpha half. The number z alpha half is a critical value that is a z-score with the property that it is at the border that separates an area of alpha half in the right tail of the standard normal distribution. Example 2. Find the critical value z of alpha half corresponding to a 95% confidence level. In order to find z of alpha half, I need to have a confidence level. Different confidence level will give me different alpha and give me different z of alpha half. My confidence level is 95%, which is 0.95. And alpha is 1 minus confidence level, which give me 0.05. I want to find alpha half. Alpha half is just alpha divided by 2. Alpha half is 0.05 divided by 2, which is 0.025. And I want to find z of alpha half, which is z of 0.025. What does this mean? It means that I want to find the critical number z that separates an area of 0.025 on the right tail. In order to do this, I am going to draw my standard normal distribution. In a standard normal distribution, mean is always 0 and standard deviation is always 1. Everything in the middle is 95%, which is my confidence level. Remember, the whole entire thing adds up to be 1. The middle part is 95%. That means this little left tail and this little right tail add up to be 5. Right? So half of 5% is 2.5%. So this piece is 0.025 and this piece is 0.025. And this number is my z of 0.025. I want to find the z-score that has 0.025 area on the right. I am going to use StatCrunch for this. To find the z-score, we are going to use the same calculator that we use in Chapter 6, Stat, Calculators, Normal. My mean is 0, my standard deviation is 1, and I know the area on the right, which is 0.025. And I want this to be greater than because that area is on the right. This is my z-score. And I get 1.95996.4. For z-score, I am going to round it to 2 decimal places, and I get 1.96. Margin of error. When data from a simple random sample are used to estimate a population proportion P, the difference between the sample proportion P hat and the population proportion P is an error. The maximum likely amount of that error is the margin of error. and the notation for margin of error is E. The formula to find the margin of error, we are taking z of alpha half multiplying by the square root of p hat times q hat over n. Here are the notations. P is the population proportion, which is the number that we are trying to estimate. P hat is the sample proportion. To find Q hat, we are going to take 1 minus P hat. N is the number of sample values, which is your sample size. E is the margin of error. And Z alpha half is the critical value, which is the z-score separating an area of alpha half is the right tail of a standard normal distribution. In order to construct a confidence interval for estimating a population proportions, we need to meet all of these three requirements. First, the sample is a simple random sample. Second, the conditions for a binomial distribution are satisfied. There is a fixed number of trials. The trials are independent. There are two categories of outcomes, and the probabilities remain constant for each trial. Third, there are at least 5 successes and at least 5 failures. Here is how we express the confidence interval. We have the lower limit equals to p hat minus e, and the upper limit equals to p hat plus e, where your p is in the middle. P is what we are trying to estimate. So if we have the lower limit and the upper limit, we're saying that p is in between these two numbers. You can either use the inequality to represent your confidence interval, or you can also use the interval method to represent your confidence interval. Round the confidence interval limits for p to 3 significant digits. Remember, if there is an instruction on how to round in a problem, please follow the instruction. If there was no instruction, please round it to 3 significant figures. Example 3. We noted that a poll of 1487 adults show that 43% of them have Facebook pages. N is 1487 and P hat is 43%. A. Find the margin of error E that corresponds to a 95% confidence level. The formula of E is z of alpha half times square root of P hat times Q hat over N. I have N is 1487, P hat is 0.43. I can find Q hat from here. Q hat is 1 minus P hat, so 1 minus 0.43 is 0.57. Z of alpha half, corresponding to 95% confidence level, we found it in example 2, so we are going to use it. If in this question they ask me to find E that corresponds to a different confidence level, I have to find Z of alpha half. Since they are using the same example that we used in example 2, so I already have it, which is 1.96. All I do is just plug the numbers in here, and I get 0.0251635693. There was no instruction here, so I'm going to round it to 3 significant figures. Which is 0.0252. B. Find a 95% confidence interval estimate of the population proportion P. The confidence interval was found by taking P hat minus E, that is the lower limit, and P hat plus E, that is the upper limit. I have P hat is 0.43. E was found in question A. All I'm going to do is going to plug it in. So E was found in part A, 0.0252, but this is the round off answer. If I want to use E for further calculation, it is better for me to use this so that my answer is more accurate than using the write-off answer. So I'm going to use this for my E. So this is what I got for my confidence interval. And since there was no instruction on how to round, I am going to round these to 3 significant figures. My confidence interval is from 0.405 to 0.455. What does that mean? It means that my P is any number in between these two. And that is 95% confidence. Or you can express the confidence interval in this format, where 0.045 less than P less than 0.455. You can also find the confidence interval using StatCrunch. To find the confidence interval for proportion, we are going to click on Stat, Proportion Stats, One Sample with Summary. The number of successes is your X, but in this problem, they don't give you X. They gave you P hat and N. To find X, you're going to take P hat times N. 0.43 times 1487. We are getting 639.41. In this case, we are going to round it to the nearest whole number. I'm going to round it to 639. The number of observations is N, 1487. My confidence interval is 95%, so I'm going to choose this one, and 95%, 0.95. Compute. This is my lower limit, and this is my upper limit. C. Based on the results, can we safely conclude that fewer than 50% of adults have Facebook pages? So if you go back on the confidence interval, we are 95% confident to say that your P is in between 0.405 and 0.455, which is in between 40.5% and 45.5%. This whole entire interval is below 50%. So yes, we are confident to say that. Example 4. In a study of the accuracy of fast food drive-through orders, Restaurant A had 272 accurate orders and 68 that were not accurate. So there are two types of orders. One is accurate and the other one is not accurate. There were 272 accurate orders and 68 were not accurate. So your N is not 272, is not 68. Your N is the total number of orders, which is 272 plus 68. Which is 340. A. Construct a 99% confidence interval. Estimate of the percentage of orders that are not accurate. We are trying to estimate the percentage of the orders that are not accurate. So my success is the number of orders that are not accurate. That means my X is the number of not accurate orders, which is 68. I am going to use StatCrunch to find my confidence interval. To find the confidence interval for proportion on StatCrunch, we are going to click on Stat, Proportion Stats, One Sample with Summary. The number of successes is my x, which is 68 in this case. The number of observations is my n, which is 340. I am going to click on this one to choose this. And my confidence level is 99% now. This is my lower limit, and this is my upper limit. My lower limit is 0.144122242. My upper limit is 0.25587758. There was no instruction on how to round. I am going to round to 3 significant figures. My confidence interval is 0.144 to 0.256. What does that mean? It means that I am 99% confident that the percentage of orders that are not accurate is in between these two numbers. So it's in between 14.4% and 25.6%. B. Find the point of estimate. Point of estimate for P is P hat. P hat is x over n, which is 68 over 340, which is 0.2. Another way to find P hat is that you're taking the upper limit plus the lower limit divided by 2. C. Find the margin of error. You can use this formula to find the margin of error if you want to. However, I have a different formula for this. I can take the upper limit minus the lower limit divided by 2 to get to my margin of error. D. Compare the result from part A to this 95% confidence interval for the percentage of orders that are not accurate at restaurant B from 0.173 to 0.258. What do you conclude? This is the confidence interval for restaurant A, and this is the confidence interval for restaurant B. These two intervals are overlapping, which means the percentage of orders that are not accurate between the two restaurants are not significantly different. So if you're given a confidence interval, you can use these two formulas to find your P hat and your E. To find P hat, we take the upper limit plus the lower limit divided by 2. To find E, we take the upper limit minus the lower limit divided by 2. Example 5. Express the confidence interval 0.222 less than P less than 0.66 in the form P hat plus or minus E. They are giving me the confidence interval. The lower limit is 0.222. The upper limit is 0.666. They want me to put it in the form P hat plus or minus E. So I need to find P hat and I also need to find E. So P hat equals upper limit plus lower limit divided by 2. My upper limit is 0.666. My lower limit is 0.222 divided by 2. And I get 0.888 divided by 2. My P hat is 0.444. Next, I'm looking for E. E equals to upper limit minus lower limit divided by 2. My upper limit is 0.666 minus my lower limit is 0.222 divided by 2. And that is 0.444 over 2, which is 0.222. Next, I want to express the interform p hat plus or minus e. P hat is 0.444 plus or minus e is 0.222. Determine sample size, estimate a population proportion. When we are trying to determine the sample size, there are two different formulas. We are using this formula if we know p hat. We are using this formula if we don't know p hat. So if you know p hat, to determine n, you're going to take z of alpha half squared times p hat times q hat divided by e squared. If you don't know p hat, then you just assume that p hat is 0.5. When p hat is 0.5, then q hat is also 0.5. If you take p hat times q hat, that is 0.5 times 0.5, that is 0.25. This is why you are replacing p hat times q hat with 0.25 here. Only use this if we don't know what p hat is. When determining the sample size, we always round it up to the next whole number. For example, if your answer is 1067.11, you round up to 1068. Example 6. When the author was conducting research for this chapter, he could find no information about percentage of adults who make online purchases. Yet, that information is extremely important to online stores as well as brick-and-mortar stores. If the author was to conduct his own survey, how many adults must be surveyed in order to be 95% confident that the sample percentage is in error by no more than 3 percentage points? So in this question, he wants to conduct his own survey and he wants to know how many adults should be included in his survey, which means we want to know what is n. He wants to be 95% confident, which means the confidence level is 95%. And he wants to make sure that the sample percentage is in error by no more than 3 percentage point, which saying this, my margin of error is 3%, which is 0.03. Question A. Assume that a recent poll showed that 80% of adults make online purchases. So this telling me that p hat is 80%, which also tell me q hat is 1 minus 0.8, which is 0.2. And I want to find n. In this question, p hat is known, so I am going to use this formula right here. I have p hat, I have q hat, I have e. Z of alpha half. This number is going to be calculated based on the confidence level. Confidence level is 95%, which makes my alpha is 1 minus 95%, which is 5%. In a standard normal distribution, the middle area is my confidence level, which is 0.95. My alpha is the sum of these two tails right here. This is 5%. So each one of those is 2.5%, which is 0.025. And this is also 0.025. And this number is z of 0.025, which is z of alpha half. I am going to use StatCrunch for that. To find the z-score, we are going to use the same calculator that we use in Chapter 6, Stat, Calculators, Normal. My mean is 0, my standard deviation is 1, and I know the area on the right, which is 0.025. And I want this to be greater than because that area is on the right. This is my z-score. And I got z of alpha half is 1.959964. I am going to round it to 2 decimal places, which is 1.96, and I'm going to plug that in here. And I got 682.9511111. N is always round up to the next whole number. I am going to round this up to 683. Question B. We are given the same information, but B saying that assume that we have no prior information suggesting a possible value for population proportion. In this case that we don't know what P hat and Q hat is. When P hat and Q hat are unknown, we are using this formula right here. Z of alpha half squared times 0.25 over E squared. Z of alpha half was found in part A, 1.96, and E is still 0.03. I got 1067.11111. Whenever we are looking for the sample size, we always round the number to the next whole number. So it doesn't matter what the decimal part is, I always round it up. So it's going to be 1068.